So here's a short video explaining my Ballistics Calculator, which was my NEA project of 2022 for computer science. Here you can see the menu. It's just a basic print screen, prints out onto the screen of the menu choices. So to begin with, we're just going to have a look at option 1, which is to enter a bullet's details. So I'm going to type 1 here. These are the bullets I've already got in my program. 22, 223, 308, 357 and 44 are just generic bullets that I researched for practice purposes. Their names simply after the caliber, so I can easily recognise them. Ely 22 is a bullet I actually use, so that is completely custom to the ammunition that I buy from the store to then shoot. Similar with the Winchester 308, but we'll enter another one here. So we'll call it test 1. Bullet speed, it's a 2.2 round. We've decided it's going to be a 2.2 round, so around 1,000 feet per second. Bullet weight, around 30, probably 30, high 30s, maybe 40 grains. So we'll put 40 grains there. Bullet caliber, as I said, we'll keep it as a 2.2. It's a very common small round. And so there we have that. Now I'm just going to show you the code. So here we have enter a bullet. If bullet choice is enter a bullet there. Bullet choice is 1. DB print ammunition name. That prints the all the ammunition names that are in the database, so you can see, and then it takes the inputs, the strings, ints, floats, and then it inserts them using this into the database, and then calls up menu again. So back to the menu. We'll enter a firearm this time, so option 2. These are the existing ones. 308, another again similar to the ammunition up here. 308 was just a test round, that's why it only has the name as the caliber, just to keep things simple. WB was another test, and Zolly is a firearm that I use. But we'll create a 2.2 caliber rifle to shoot the new bullet we've just made. So we'll call it test 2. Barrel length, we'll say 18, 20 inches maybe. 18, there you go, 18 inches, that's a nice length. Scope height, 2 inches, that's a very common rail height. This is the height above the centre of the barrel that the centre of your sights are. This is essential, as all of aiming is basically it's getting the bullet to hit where your line of sight is. So that is the imaginary line from your eye going to what you're trying to hit. So your line of sight at 0 yards is already 2 inches above where the bullet's going to hit. Caliber, put it as 2.2 since it's a 2.2 that we created. Zero distance, put it as 50 yards. So 2.2s aren't massively long range, so we'll keep it nice and simple. Again, it takes us back to the menu, so we'll just have a look at the code here. LF choice 2, prints firearms, so that shows us what's in the database already. And then again, similar to the bullet, takes all the inputs and then inserts them into the database through these statements here. And again, it then calls menu. So I'll bring this back up. Now let's shoot with these two weapons, the rifle and the bullet that we've just created. So there's option 6. Which firearm would you like to select? So these are the firearms that are in the database. And we're going to use test 2 since we've just done all that effort to create it. So test 2, so I've selected test 2. That's the name of the weapon. 18-inch barrel, 2-inch scope height, 2.2 caliber, a 50 yard zero distance. So these are all the characteristics we've just set up here. Now we have to choose a bullet. we use test 1 since it's a bullet we've just made. So now we've selected that, it just again verifies you have selected test 1, 1000 feet per second, 40 grains and a calibre of 2.2. So now it says the drop result at 50 yard intervals. I would have liked to put this in a table in a GUI, however I couldn't quite link the this code and my TK Inter code in time, which is a shame, but this code works and it works well. So it says in inches and an MOA. MOA is minutes of angles. That is something that is used in the shooting world. It's essentially 1 inch of spread at 100 yards. So 1 MOA could also be 3 inches of spread, or it drops 3 inches at 300 yards. There's lots more writing about that at my in my documentation. So since the rifle was zeroed at 50 yards, so at 50 yards the drop is 0. That's where it's zeroed at, and that means that the line of sight directly intersects with the bullet's trajectory. If you imagine some imaginary lines, these two directly intersect at 50 yards, and that means the bullet is going to hit exactly where you're pointing. So say I'm shooting at 100 yards, this is this measurement here. At 100 yards it will have dropped 6.8 inches. That corresponds to 6.81 minutes. So you would adjust that on your scope. You normally have a small dial or something similar to adjust, make your adjustments and measurements. So we'll just have a quick look at that here. We'll scroll down to choice 6. So you print the firearm, select them. We choose the one there. We select the firearm, and it just verifies there. This was just in my in testing. It was just printing testing that the object was actually created. Now I've put a hash there since it doesn't need to show that to the user. Just the same thing with the ammunition. We just have a little bit of fail-safe stuff here. So if there's nothing, if the drop result is none, prints something's wrong, return to the menu, and then returns you to the menu. However, if it's not, it passes the 2 inputs we've had into calculations.calcdrop. So that's a method which uses ammunition and firearm to calculate the drop, and it then prints the drop result at 50 yard intervals is in inches and then MOA. Drop result is something that's previously determined up here. I'll just bring that up for you. Up here we go. So calc drop, this is the method that's used, passing all these variables and stuff, and then there's much more in-depth stuff on my documentation, and then it returns drop table and MOA, and that basically prints it out to where we want it down here. So looking back at this, through my testing, you can see in my documentation that when you use these numbers and you make these are the adjustments here, since these digits up here are the just the physical drop, these are the adjustments you want to make. So that's all nice and good. I forgot to mention earlier, environment details, these are preset from when I was last using it. Just say it's a nice warm day of 20 degrees, we're at no elevation, keeps it nice and simple, so that gives you an air density of 1.25. So that gives you an air density of 1.25 kilograms per meter cubed. It's slightly above regular, that's just due to the temperature. That changes obviously with your temperature and elevation, and this affects the bullet's trajectory because of the bullet has to simply overcome a greater force when travelling. So we'll have a look at some of the other options, like to remove a bullet or firearm. Say that we don't want to use test 1 anymore, so we'll click 3. Delete firearm bullet. Let's delete the bullet first because we've decided we don't want test 1 anymore. So here it is labelled there. We're going to delete test 1. It's deleted it there, and in the database you can see we'll do 4 view stored data bullet. There is no test 1 anymore, so it has been deleted from not only the program but the database as well. Same thing works for firearm. We'll just remove the firearm, test 2, F for firearm, test 2, deletes it there, and we can again check it in by searching the database, and as you can see there is no test 2 anymore as it was shown up here. So that's all of the program so far. Unfortunately I could not link it to a GUI. I created a very basic one, but could not link it together in the end, unfortunately. I should have coded them simultaneously. However, I focused far too much on the mathematical side of the program before thinking too much about the other stuff. But we'll just have a look at the last couple methods we've done there. So in here we're just going to look at choice 4. So this is the selection, db print ammunition name. That's method prints out what's in the ammunition database. It prints out the names, not all of the data, since you just want to select the bullet by the name. You can see up here we've got some SQL queries that I have to find it quickly. Delete firearm, it's the same, exactly the same as delete ammunition. So with SQLite 3 connect, try delete from ammunition where bullet ID is, and then simply the user input. Same goes for delete firearm, and yeah, gets it done. And then just to finish off, I'll just type 0 in there just to keep the program happy. Just to finish off, we'll click 7 to quit. Actually, before that, we'll just prove that you can use preset and pre-stored values. So we'll just do another calculate drop. Use the Zolly. That's a gun I quite often use when target shooting. It's a 308, so quite a large gun. And we'll just choose Winchester 308 as the round, since that's it's another ammunition I buy from the shops. It's cheap, hence why I use it. So again, the drop result of 50-yard intervals in inches goes on there. As you can see, the drop result is 0.001 inches at 100 yards. That's virtually 0, but as I've mentioned in my documentation, my equations aren't 100% accurate. They're pretty good. They're very, very close, but they're not quite there. But that's certainly good enough. You're not going to notice 0.001 inches of difference, since there's probably more user error than calculation error when you're inaccurate at that sort of range. So then again, since it's zeroed at 100, you got a virtually 0 there, and then no minutes of accuracy, minutes of angle here. So say we're shooting at 200 yards, 100 there, 150, 200, so you drop in 2.2 inches below line of sight, and that corresponds to 1.1 MOA. So you make that adjustment and it works. And what I've just done here is prove that with the preset you've seen in this video, I haven't entered these today. These were from shooting at the weekend. These are like preset, they're stored in the database, so even when I close the program and quit, as I will do very shortly, the data doesn't go anywhere, which is helpful. So quit 7. And as you can see, elif choice 7, you've chosen to quit, and it just calls a basic quit function. So we'll call that up, 7, there you go, shuts down, and that is my NEA. Thank you very much. Here's just a quick overview of my menu. It doesn't quite work, unfortunately, but it's got the imported the main code, and then I've tried to create some functions and stuff here. This is the tkinter side of things. So this, you see it just commented here, ender code for written interaction. That is the program we've just previously looked at. And then my menu equals menu root. We've got some other stuff called here. So we've got some subroutines and stuff there. Unfortunately, this doesn't quite work, but sorry about that. Here we can see that we create menus, and then we cascade down with the options and stuff like that. That in itself all works. And just we create more menus and more labels, and we'll just run this quickly. And as you can see, it comes up, you got all your buttons and stuff. These were the main options. And yeah, it's a shame it didn't quite work, but bullet name, bullet speed, it wasn't quite finished. But as you can see, firearm name, scope height, these are all the stuff that it needed to work with. So when you calculate drop, you want to select your bullet and firearm to calculate on. Quit, that does work. That is one of the only things that works in here, since I, again, like I said, wasn't fully able to tie it together. But there you go. So thank you very much. That was my 2022 NEA project for my A-level computer science. Thanks again.